Hello. In this short recording, I worked a few problems that you have in your textbook, and that should give you a guideline about how to solve the problems I gave you for chapter 4. And so here I have a production function, okay, as a function of x1 and x2. I have p on price of input 1 and price of input 2. I want to find out the least cost combination, okay, of x1 and x2. So if you have x prices, okay, the least cost combinations is the formula that we had before, that the two slopes are equal. Slope of isoquant here and slope of, because price of x1 and x2, okay, are the input prices, right? And so the x's are the input quantities, okay? And so given the information about output function and input cost, right? You are asked to find how many, what the output level, okay, that needs to be produced to maximize. No, the least cost combination. We're here to minimize cost. Okay, what level output needs to be produced to minimize cost? And so you take the derivative of x2 divided by the derivative of x1, and you equate it to the ratio of prices. Equals, so right, basically it's equal to 2 divided by 4, and you get this value here, right? And so here I'm showing you the details. So basically, this line here, okay, is the detail of how I got this equation here, right? So x1 divided by 2 x2 equals 1/2, okay, because that's the result I have. Okay, I'll show you here, right? This is to get this. I get these equations help me get this, okay, this result. And that result is here in ratio of prices. Once I have that, I can, but in this case, it's happened to be 2x1 equals 2x2, so x1 equals x2. And so you need to know, okay, if you want the number, and they ask you that, okay, if you know why, the output being produced, then you can find the exact quantity of input number that can be produced. So it's really not different from what we have done before. Same thing here, okay, different numbers, and the question here is different, right? Even though it's the same thing. When you ask what is the expansion path, right, it's the same idea, the same formula. You're trying to find out the optimum x1 and x2, right? And so we set up the derivative of each production output with respect to each input, right? And you study it up to the ratio of prices. Here you are given that, and so the question here, however, is slightly different. We're asking the optimum criterion for the two variables. Okay, the optimum criterion for the two variables, and that optimum criterion for two variables is this formula here that we used before. You apply that, and you know, it really goes smoothly. Okay, here's the simple functions. So we have this number first, and so we have an information somewhere. Well, right, exactly. We are given not only the price of each input, right, but the total cost. Right, how much would these inputs cost? And so what is the cost? The cost is, of course, px1 plus px2. And so we set that up Okay, so we place by, so price of 1, price of 2, that equals to 1,000 still, right? And so um, so for x equal 1,000 always, right? And so 1,000 equals for x1, and given that, I can find x1 is equal to 250, right? Because 1,000 divided by 4. And if I know x1, okay, equals 250, then price times x1, 2 times x1, okay, is 500, and so x2 can only be 500, okay, because this is the cost. The price of x1 is 2. So if I multiply, so because this is cost, okay, how much does it cost? So the optimal criterion, so multiply the price by the quantity that I know, 250, and so I get the cost of x1. Once I get the cost of x1, that is so 500, then I know by deductions what the cost of x2 is going to be. And so that should help you solve the 2 problems I gave you in this class. Thank you.